Hi everybody. Sorry it's been such a long wait. Turns out these pedals were a much bigger project than I anticipated when I got into them. Turns out your legs are your strongest part, so there's a lot of engineering and thought that had to go into making these work really well. But today's the day. It's public, it's free to download, completely open source, completely open hardware. Remix it, redesign it, do whatever you want with it, and make your own rudder pedals for your flight sim or space sim or helicopter sim, which I'll show you a little bit of that later. It's really great to finally get these things out, and it wouldn't have been possible without my Patreons, which have had access to the work in progress files for the last little while. But for them, they've made this whole project possible. There's been so many delays due to my traveling for work, my original printer giving up the ghost, which thankfully I now have upgraded to Bamboo Labs, which I know there's a little bit of a controversy with them, but it's still a very good printer. And I mean, I got to print a lot of iterations and a lot of prototypes to get to this stage. But it's here and it's ready for anybody to download and make their own. And these pedals are fully compatible with the original gimbal. They'll actually mount directly onto them, as you saw earlier. And that's going to make it kind of a complete system that you can either build into a sim pit or you can use with the wheel chocks. The one thing that I'm working on as my next project is a complete open source grip that'll go on top of the gimbal to replace the Thrustmaster one. Thrustmaster grips have kind of fallen out of favor. They're not really the best thing on the market anymore, and I don't really have the time at the moment to modify the system to work with other grips. Different grips have different protocols that require different electronics. And there are projects that are out there that people have modified the gimbal, but I think the best solution is just to have a completely new grip design that can mount directly onto it so that the entire system is fully manufactured at home. The other interesting thing about this grip design, which is just an early study model, is I actually want to modify it so that it also supports mounting on these old Thrustmaster joysticks, because these joysticks have, let's just say, a shaky reputation. But one of the things that is actually quite good about them is the sensitivity of their sensor. So they're actually really great for space sims and stuff like that, except they have a really terrible button layout. You have very few buttons on the grip, but as a project I did many years ago, you can easily rewire to the buttons that are on the base, at least these 6. So the idea for this grip is that it'll be designed with a clamshell that has an insert, and either you design it for putting it onto the gimbal system or anything else, or there'll be a clamshell that'll fit over the stem of these guys. And what's really great about these Thrustmaster T16000, 1600? Yeah, 1600. 16,000? I don't even remember the number. Yeah, 16,000. The T16000s is that they're actually really cheap if you get busted ones. So this one I got for like $10 because the grip potentiometer is blown, but we'll replace those with a Hall effect sensor and it'll work even better than it did when it was new. So this is going to be the next project that I'm going to work on after the pedals. But one of the things that I definitely want to do is continue to build out this ecosystem. I want to, get the pedals designed and eventually maybe get some sort of throttle mount. And then I'm not super interested in making an open source throttle to go with the system, simply because Authenticate has so many really great throttle options that are out there for all different kinds of warbirds. And now with IL-2 Korea coming, they're also working on like early jet throttle quadrants as well. So there's already a really existing system for that. But one thing I think would be nice to design is some sort of mounting bracket that brings up a throttle next to you. So when you use it with an office chair, it's all kind of ergonomically in the right spot. But yeah, so it's been quite the journey to get here, but I think it's going to be really great. And I think all of you guys are going to really enjoy the pedals. So let's go straight to the build guide. So this is the hardware that's required for the pedals. You can see it's a great many different sizes, but I've tried to reuse sizes whenever possible, simply so that you can buy things in bulk. So I've avoided as much as possible single-use bolts. There's a couple of things like this long bolt that we only need 2 of, but for the most part, everything is duplicated as much as possible. There's also optional parts here. For example, this damper system is optional, as well as these rotary dampers. Now, these ones are a little bit tricky to get now because of, tariff silliness. The Authenticate people have an alternate, which I haven't tested yet, but might fit as well. So these are also optional. If you're using this, you don't really need this. So that's an optional piece. And then there's also some things where, for example, the breakout board from the main gimbal, this piece is also an optional thing to use. It's simply from when you order from PCBWay, there's usually a minimum order, so you might have a spare one of these. So why not use it for this purpose? But you can, of course, just solder directly to the microcontroller, whether it's Freejoy with the blue pill, or it's MMJoy or straight Arduino with the Pro Micro. So these are options as well. But yeah, these are all the parts that we'll need. We'll need tools, obviously, such as all the different kinds of Allen key sizes, a couple of Phillips heads, might need pliers, we'll need wrenches of some kind to work with these bolts, especially if you have hex-headed bolts. It will be very valuable to have, you know, a ratcheting wrench. There are some parts that are threaded, that take threads directly into the plastic, so it's good to have a tap set, metric tap set. This is just a good thing to have in general. If you have a 3D printer, it's very useful to design parts that, you know, there's a single-use thread or only being screwed together a couple of times. And while you can print the threads, it's always good to be able to clear out the plastic with an actual tap just to make sure it threads nicely. And of course, there's soldering, which we're not going to do all the soldering in the video today. I'm going to save that for a separate video, but I will run the wires just to make that clear about where they go. We've also got, oh, just to get that stuck in there, soldering iron of some kind, of course. For wire, one of the ideas I have used on the prototype is I actually just use old USB cable wire that's fairly flexible, because this has 4 conductors in it, and we only need 3 for our sensors, so this is useful. We also will need these Hall effect sensors, or that's something that is possible with this design, or potentiometers. So you can use a potentiometer for the rudder, or you can use Hall effect sensors, both for the rudder axis itself and for the toe brakes. Obviously, I suggest working with the Hall effect sensors. It just has, you know, less potential for wear because there's no moving parts for the sensor, so you'll get less, you know, jitter over time. But I also recommend buying high quality, like the Allegro brand ones. I think they're the 1352. I'll have to double check what the model is, but those are the ones that you want to get, simply because the SS49E, which is recommended by a couple of different projects, which is cheaper, a little bit cheaper. It gets a lot of noise when it's running at 3.3 volts. And because of the cables that we're running on, the long lengths of the cables, you end up picking up a lot of electrical noise. So it's better to get higher quality Hall effect sensors. Finally, one option as well is that if you have the leftover sensor PCBs that are recommended for the main gimbal, you can also mount one of them for the yaw as well. You can substitute it. So if you want to go that route, you can use one of these. But it's only if you've got a spare. We're not going to use that today for this project. Okay, so next up, let's go through all the parts. A lot of these parts are duplicates or mirrors of each other. So it looks like there's more parts than there really are in reality. But it is, I don't want to say complicated, but there are a lot of systems, subsystems, and submodules that go together. So let's first concentrate on the main module that makes up the heart of the pedals. So let me remove all the parts that we don't currently need. Okay, so when we think about the pedals, the main heart of the pedals is this clamshell right here. This is where all of our pieces kind of mount onto when it comes to the yaw action, the wider pedals, and of course, how it mounts to whatever surface you're mounting it to. Now, there's a new design consideration in how these parts are assembled, in that even though I said that there's a lot of things that are threaded directly into plastic, there's actually a great many nuts that are inserted into slots into the part. So you can see here, I can just drop a nut in there. And if I use, let's just say, you know, a flat-headed screwdriver, I can just force them down in there. And then if you look, you can see there's now a thread, which I can now thread a bolt into. So let's actually go through in this main part and insert all the nuts that we need. So I just put one M5 nut in there. So we insert our nuts into there. These are just M5 nuts. And just to hold them in place, I'm just going to put an M5 by 16, which is what eventually is going to be here. But by inserting the nut first, I can actually use the top of the screwdriver to hold the nut in place so it doesn't try and spin on me. And just get it on there. Okay. And get my M5 driver. Just it can kind of be a little bit tricky to get it started. The nuts might sometimes want to bend back, but here we go. This one's going in. And yeah, I'm just putting these bolts in just to hold the nuts until it gets time to actually use the part that those are mounted in. And you can see there, now the nut is captured by that bolt. See, grab it nice and tight. You can do the same to these ones. A good tool to have, you can look and find these things on Thingiverse and other 3D printing websites, are little bolt measurers, and you can place the bolt in there, and here I can see that it is a M5 by 20. These are good to have. One's being a little bit temperamental, you can sometimes give it some love taps just to get it in there. There's a little bit of, there's like a 3D printed little glob in there that's kind of getting in its way. So you can see that the filament color changed part way because it ran out. So there's a little bit of a friction getting that nut in. The other interesting thing too, if you ever need to remove one of these nuts, there are these 1.5 millimeter holes that you can just use a little pin to punch them back out. But yes, let's get this front one attached. We'll eventually be loosening these back out so they don't need to be all the way tight, just enough that that bolt doesn't go flopping around. Okay, so we've got the M5 ones into this part. Let's do the M8 nuts. So we got M8 size. Those drop in there. Now you have to make sure that these are properly sized nuts. And the M8s go in like this. So the point is down. This one's giving me a little bit of trouble. Again, because of that, there we go. Because of the change in color. There, let's pop that one in. And then these will be M8 by 35. You can use socket head. You can use hex head. I'm using sockets. And then this is actually, yeah, this is 35. I can go in there. You can just hand tighten these down because we're going to loosen these back off in a minute. We're just getting all of our nuts in so that we don't have to fight to find them later. And you know, the nut can sometimes slide out when we take it apart to put a new part on there. We just have to make sure we orient it so the nut doesn't fall out or slide up. You know, you can see this has a lot of travel. There we go. And you can see there's the hole for punching those nuts out as well. We've also got two at the back here. The other thing too, if you ever get a nut stuck, you can kind of stick it in there to pop it back out if it's not all the way in. There is good tolerance in these slots. It's just the change in filament seems to have created a little bit of a, like a little bit of a lip on the inside. Yeah, so if you're going to use the AMS, make sure the two filaments that rolls over similar brands and colors, so you don't get like this interface. Okay, so now we've got this guy mostly bolted up. One last thing we want to do, which is there are M3 threaded holes here that we're going to be using. So what you could do is you could take an M3 nut and just take a lighter and heat it up and then drive it in. That's one way of cutting the threads. Or the correct way, I think, is to just use a tap. And just start the thread. You don't have to necessarily thread it completely, but just enough to start it. You know, and I find the smaller threads have the most amount of trouble, like that need the tapping the most, at least to start it. Right. Just enough. There's an M5 one there that's printed thread, but it seems okay. The printed thread here seems okay. If it was giving you trouble, your printer's not super calibrated, you can tap that one too, but it seems fine here. Okay, so that one's tapped. This is the bottom of our clamshell. This will be the top. This also has some nuts that need to be inserted. So I have some M5 at the back here and M5 at the front. Okay, so now that these are set up, ready to go, put them aside. Now, we have the aluminum extrusion, the 20 by 20. This one in the design could be straight, but I'm using two short pieces and I'll show you why later. But for the main bars, the front and back, we need these two, right? And then we have these two sleeves. That's the front and back sleeve. And then those sleeves will then sit in here. Now we don't have to center them exactly, but I'm just gonna push through, make sure there's no crud in the middle there. And then with the front one and the back one, we have to make a couple of decisions at this point. With the front one, we have to decide what kind of magnet system we're using. Are we going to be using these ones? Because then they come with a very specific magnet that just sits in the face here. Or are we going to be using a regular Hall effect sensor? In that case, just one of these 8mm by 3mm circular magnets can slot right in there. Might give it a little dab of super glue. And then in the back here, there is an option for inserting magnets here. And then there's an extra part that'll place a Hall effect sensor facing down to detect between these two magnets. This requires complicated curve. You have to correct the non-linearness of this motion. So it ends up being a big pain. You can do it if you'd like, but it's not necessary. It just means that you saturate the voltage difference. You get more resolution, but I don't think it's necessary for most use cases. It's an option, but that requires mounting, or that doesn't require. That can also, in that same point, we can mount these gear teeth, because this is the option with this extra piece for mounting a potentiometer here instead, and that's how that can also read the position. So you have this potential for reading the position of the yaw, and you have this option either with a gear or with these magnets that go in here. You can mount this gear anyway and decide later, but here is also some tapping. You can just tap this M3 hole right here. Okay. But also, speaking of tapping, tapping these ones, because this is the other optional decision you can make. I just tap that. I'm just going to tap this one side just to show. This is where these rotary dampers can go. They can mount in here, right? And then these dampers, when they're mounted in here, run against the teeth that are here. Now, I actually am using these dampers simply because I bought dampers by mistake that are only damped in one direction. See that? It turns easily one direction and is dampered the other. But if I mount them on opposite sides of each other, then they will rotate opposite to each other. So they'll damp in both directions. You know, this will damp this way, this will damp the other way. So it's a way to use them up, and you can put a maximum of 4 of these dampers on here. So I'm actually going to mount them before I put it over the extrusion. So yeah, so I tapped those already, and then that will take, I believe, the M3x6, I think are the bolts for that. If I look, yeah, I think it's these. And what I can do is I can just kind of start one. Is that the right? Yes. I'll just start that there. And then once it's started, with these anyway, you can slot them in. The authenticate options are shaped differently, so they'll need to be like a little adapter or spacer that you have to use with these bolts. I haven't got any on hand to test yet, but they should theoretically fit. But I can't verify that. But yeah, let's tighten that down. Do the same here. Okay, you don't want to over tighten it that you strip the plastic. But there you go. You can see this doesn't dampen that way, but it dampens that way. So for me, I have to put them both on the same side so they counter each other, because they both are, I think, right hand only damping. It was not very clear in the product number when I bought them on Amazon many years ago. And now they're not on Amazon. I don't know why. It's all that tariff silliness. So yeah, you can see, start the thread. Get that in there. Get that down. Okay. Oops. Okay, that's good. Now we can put this on. Same screw. There we go. That's nicely done there. Now, the next thing is we have to put, on both of these, we have to put a M5 by 8 mil in there. But here's the thing. Because it goes on the extrusion, we need to put these hammer nuts in. Now that can be a bit of a bitch, because you got to get this guy. I actually just wet my finger, stick it on there, slide it in till I see the thread, and then get it on there, those threads. Just get it started so it grabs it. Later on, you're going to have to line up all the things so the extrusion catches them. But you see right down there, it's mounted. On this one, I've got that 5. These are 16s. So that'll be a 16 that goes there, but we don't put these on just yet. We're going to start with the 5s, because I also got to put the 8s, the 8 mil lengths, because I got to do them here as well. That's an 8 there. There you go. Just grab these 2. Wet my finger. Slide that up. Before I figured out the licking the finger technique, this was a real pain in the ass. But that just goes there, and just get it enough just so it's grabbing the threads. Not super tight because it needs to be loose so that the extrusion can catch it as it goes by, you know, because it's like a hook. So you want to make sure that it's, when the extrusion, it's loose enough, because if it's too tight, it'll just get pushed. Okay, those are mounted. The next thing we're going to need is our bearings. Okay, these are the larger bearings. They are the 6003, I believe. Yeah, 6003 bearings. These just force over there. You can push them on. You might need to hammer them in a little bit depending on your tolerances. If they're loose, maybe just put a little bit of Kapton tape or just a shim in there just to make it tight if it is loose. Or you can use some extra purge line, like filament that your printer puts as that first line on the bed. You can use that as shims too, and you can shove it in there and then cut it off with flush cutters. Put that one aside. This one is going to need our bog standard skateboard bearings. So these are the 608s. These are super common. They're used for everything. Those go here. Those slide right over those. These don't have to be super tight because this is the back bar, so it's not as critical. And now that these are on, we can do the 16, put those in. I'm gonna take this one off. Retouch that in a minute. If you don't have long fingers, this can be a little bit tricky. Okay. Oh yeah. Get the bearing over top. Slide that in. Oh. Yeah, that's very tricky. Promise you, this is the hardest part of the build. Take this one off because those are blocking my finger. Okay, I've got that one. Bearing on, same thing. Okay, put those back on. Ones at the ends are easy. Okay, now, gotta put this through. Kind of have to wiggle it, jiggle it. Might go in here and kind of torque these guys a little bit. Trying to get them straight. Maybe go in there with a screwdriver. Kind of point them, go in there with a screwdriver and kind of just point them in the right direction so that they're in line with the track, so that the track can slide smoothly. There we go. I got it. But you can see here what I'm talking about, right? You can see how at an angle, just try and straighten it so that it goes over, right? Because that's got to go through there. Now we can adjust this later, but for now, let's just get it vaguely in the center and tighten our nuts so we don't lose any of them. So just give it finger tightness right now. Okay. Put that there. Put that there. Okay, that one's on. Now we get to do battle with this one. This one's very close. I'm just adjusting the nuts so that there we go. Okay, just gonna just tightening them. Not super tight yet. We'll tighten them down once we have it centered. Now we got to do that with these 4 guys. Same thing. The bearing goes over. In some instances, if it's really giving you trouble, you can kind of delete these ones if it's really giving you a lot of problem, because they're not super necessary. Like the prototype one that I use, like for actually my flight sim setup, because this is the working one of the final design. It doesn't have them. This is easy to just kind of line them up and stick them over the end there. Make sure you can kind of look down that way to see if they're lined up. And you can check that hole there to see if it's all the way flush. So you want this sitting flush. There we go. That one's, oh, aha, fell right off. But at least it stayed aligned. These ones, once they're on, you can really give them the beans, keep them on there nice and tight. Now, the reason why we didn't tighten this all the way is I actually have these gauges that I made that'll tell me if this is centered. Is it this gauge? I can't remember. I made 2 versions. Okay, so this is, it needs to go over a little bit that way. That one needs to go that way. And actually, just for sanity's sake, since this is the orientation, I'm going to make this side of the gauge flush. So I don't lose my, so I just loosen that just a little bit. Don't loosen it too much that you lose the nut, because then you're in a real world of hurt. But there, I can adjust that. You can measure this as well. I just know the length of these pieces, so I just made these gauges. But you can do it with a ruler as well. So yeah, so that's kind of there. And that, oh, so actually, yeah, so the trickiness with this one, if I remember correctly, is with this gauge is different on either side. Yeah, because this one's not centered, it's a little bit longer here. And if you don't use these screws, you can actually adjust this after it's assembled. So I'm going to say you don't have to use these screws, but it's in the design. I didn't delete it from the CAD file, so we suffer together. But yeah, I think just get rid of those. Don't install them if you don't have to. Okay, because this gauge, this side is equal. So actually, that one's pretty good. Oh, it's actually, I had this one gauged incorrectly. So this side is actually supposed to be that side, because this is longer. give it like a 1 turn of the screw. So this is actually the short side. No. Yeah, it's still not, oh, I missed that one. No, why is this not moving? Here. It's that short side of the gauge. Like I said, you can do it with a ruler. I'll include this gauge in the file if I can find where in the Fusion file I made it, because it should be in the project file. I just have to include it in the STLs. Okay. Now I can see if I line up the ends. I use a top camera. Those are equal. Okay. Set that aside. This is our bottom piece. Let us put our bearings in. So, actually, there's one thing I want to say before I proceed. So if I just, I forgot before, there's also in this piece, there are also M3 holes here that you don't really need if you're not going with potentiometers. Okay, so if I just start those holes there. Because there's this piece. I've already got it assembled, but it has the thread on there. And that will actually go in here. And that's how you have potentiometer option. So then that, if I force it into the mount, you can see that, of course it's not being held tight, so it's moving because it's loose, but you can see, oh, it's because of the, there's actually a little arrow here that you can rotate to kind of find where the center of your pot is, just so you make sure that you're not saturating it. In fact, I always go to just one end, take it to the maximum amount, and then just take it back a couple of turns. There you go. But yeah, so that's where the potentiometer option would go. And if you were going to do that, you would just run the 3 wires from here, just out of the back here. But we're not going to go with the potentiometer option, so we're just going to leave this out. But you can see here, it's kind of hard to see on this side, but the damper, let's see if I can catch the light with it, is running in that gear. I'll put this one on. Trying to push it in. The holes are ribbed, so there's a little bit of give to them, so you might have to give it a little bit of a tap. And again, if it's not snug, you might have to put like a little bit of filament or some Kapton tape or some shim just to tighten up the hole. There we go. Push that together. There's our flappy flap, and here what I was talking about, you look there, you can see the gears, and yeah, this is now damped. Now, if I was using this for helicopters, I think 4 of those dampers would be enough to kind of have a nice damped feel for pedals on a helicopter. But of course, the piston damper gives you adjustments right on it, so, you know, it's whatever one. And this is potentially cheaper as well, or more expensive depending on where you are, what the tariffs are like, you know, all that craziness. But yeah, so this is there. It might bow a little bit here because it's supposed to be under compression. So that'll tighten up when we add those bolts. This version, I didn't print with support, so there's a little bit of ragginess in the holes. That's fine, it'll be covered up. But the thing that we have to do is we have to do another tap. So this is the tap, this is the mount for the rollers for the cams. And I suggest tapping it just so it doesn't split, right? You still want this screw to be tight, but you don't want it to split the plastic. So it's good to give it tap. First, I need to change to the big size. You can also do it, like I said, with a lighter. If you're gonna do it with a lighter, just go slow that you don't melt the plastic too much. And also, don't tap it 100% to the bottom. I turn a little bit, turn it back, turn a little bit. There's printed thread, so it kind of wants to find its own way. But I don't tap all the way because I still want it to bite the bolt. Now the bolt will have a lock washer on it, but still. not going any deeper. Now, this is the part of the video where I'm desperately trying to remember if there's supposed to be a washer underneath there, but I don't think so. Here is where I'm going to use the hex head. I think it looks better because the other things will be exposed hex. So, but that, then we take, oh boy. Oh, there's a magnet in here that's fighting me a little bit. Okay, there's our lock washer. There should be a couple of these lock washers actually. Why is there only two? I don't know why there's only two lock washers. There should be a third one, no? I think I'm missing one of my lock washers. Oh well. Okay, so we'll do this without a lock washer because I do need the lock washers elsewhere. So we won't do a lock washer on that. It should find, the plastic will bite it. It won't, because we didn't tap all the way, it'll bind and it'll hold in place. Yes, so this is again a 35. It has to be a specific length because it's obviously going to be stopped. Now, if you really want to do this right, you can drill a hole into the extrusion and tap the plastic and then use a longer bolt. You know, something that'll go into the plastic, or sorry, into the metal, or go all the way through it and try and recess the nut in there. But I want to keep the design simple enough for most people, so I didn't want to do anything that involves drilling into the extrusion, because from, you know, these scraps that I'm using here, it's a tricky process. Ignore these holes, they're not required in the design. This is from an old system. But yeah, you can see it's a real piece of shit. But yeah, so we take our M8 by 35, we put our bearing on there. We have a spacer, separates the bearings from each other. Take another one, and then we thread that in. And this is where having the wrench will be useful. Of course, 13 mil socket. I'm just going to I want it to be nice and tight. I don't want it to crack the plastic. So if I feel like the plastic is not happy, I'll stop. But I'll give it, yeah, give it a good, just don't go far enough that the plastic's gonna split on you, because the layer lines are this way so it can open up. That's why we tapped it. Yeah, that's pretty good. And that's tight enough that this is not gonna loosen itself out. So I guess there wasn't a lock nut on it. I think the lock nuts are for these because that's metal on metal and that can work itself loose. Okay, we got that on there. We got this on here. I think now is the time that we make this clamshell a clamshell. So that's where we take our M6 by, M8 by 60s. Those go through here. These ones do have to be round head because they go flush. And then they go into the bottom here. And I believe these are regular nuts. They're not lock nuts. Take our Allen key in there. I'm just gonna hold that Allen key and just, right now I'm not tightening it all the way. You know, a good point of practice is whenever you're tightening something that is like gonna be compression held together, that's like clamping, start on opposite corners. So you do this corner, this corner, this corner, then this corner, and that way you distribute the tension, the load into the part more balanced, right? And you don't tighten it 100% on your first go. You just get everything, you know, here I'm just tightening enough that it closes the gap. Okay, so I haven't really reefed that in yet. I just tightened enough to close the cap. Now I'm gonna do this corner. M8 nut. Oh, doing that backwards. So I'll just tighten that for now. Okay, the reason why I'm stopping there is because now these two are big bolts, are 100 mil 8 mil. This is hex at the bottom. It doesn't have to be hex necessarily, but it's better because it'll be smaller on this side if it's hex. That just goes through both of them. And now here's an interesting, not interesting, but a specific thing. This actually needs a nylon lock nut. And that nylon lock nut, now this is going to take a while for you to thread in, and that's why I recommend a ratchet, is that you got to start that in. Okay. Threads are being annoying. Why is the start of this? Oh, I see the thread got nicked, got banged. You see how it's bent there. There you go. Okay. Now I'm saying why you need the ratchet. Because this recesses in here, and then you drive it through. So. All right, so I'm gonna keep my finger on it. You can see it's working its way. And now this will be the first corner that we tighten all the way, and then we'll tighten up the other corners. I know, let's just do this. It's faster, right? Is it faster? I don't know. Okay, that's starting to get flush. Yeah. There we go, nice and tight. And now, since I've tightened that all the way, I'll move over to this corner, tighten that all the way. And all the way just means that, you know, you feel that it's really binding, that you really, you know, you feel that you've put some pressure in. Not enough that you feel like you're gonna break the plastic, because, you know, you probably could. But enough that you can feel the beginnings of it starting to really get compressed. Right, because you really want to reduce any flex, especially since in my case I'm using PETG, which does have a little bit of flex to it. If I was using ASA, it might be a little bit more rigid. PLA Plus also is pretty good, except that it will creep over time. It'll underload, it'll slowly start moving. Okay, and now I got to do this one. That's nice and tight. Now let's do the cams. So actually, let's not do the cams yet. We'll put the pedals on first. So we can put this aside for now. These are our pedal carriages. This is all the same part. It's just, they go together like that. Now we have 1, 2, 3, 4, 5 nuts per thing. We only need to install these nuts on the outsides. So this one and then this one. So only two sets will need these nuts, and you only need these nuts if you're using toe brakes. If you're just using straight pedals, you don't need them, but I always suggest installing them because you never know if you want to upgrade. Now, I believe these are 20s. I think these are 20s. It might be 16. Let's see when we get further on in the process if I got to switch some of these 20s to 16, if I run out of 20s elsewhere, but I think this is all 20s. Yeah. Okay, we've got these two done. Oh, my knuckle. Okay. Now we've got these. Take that. Stick that there. The one with the outside, it goes on top. Here, we need the M5 by 50s. Those go through there. This one, we're gonna have to take them out later, but for now, we'll just mount the top ones. These ones come later. Right? We can see the beginnings of the actual pedal mechanism. Exciting. Remember, this goes out. Okay. That's what the pliers are for. Okay, look at that. We've got pedal mechanism. You see that? These are your pedals. Your feet go against. This is where we'll be mounting stuff. This is for the cams. Of course, you can see though, just with those two dampers. Like, I mean, if I was just making a helicopter set, you know, I'm pretty much there. You know, get two more of those. Feel pretty good. Okay, so let's put the cams on. Now, it uses the exact same cams that the main gimbal uses. That comes in soft, medium, and hard. Depending on what you're going to be using this for and how much damping you're going to have, I would suggest medium or hard. Medium is okay for warbirds, but you still kind of want to have a good center idea of where the controls are when you're in a jet. Soft is quite soft. It'll have a very loose center, which is, you know, if you're doing like World War I Rise of Flight, sort of, or flying circus, or you're doing gliders or something where like the center position is really undefined, soft is perfectly fine. Otherwise, I would definitely recommend medium or hard. And these go together just the way they go together for the main gimbal, together. So the same as the gimbal, you just push the bearings in, there and there. They just friction fit. Same here. Force those in. Now we've got the M4 bolts. Those just thread in. Now these ones, I recommend not tapping too much because we do want them to really bind so they don't loosen out. Just thread that in most of the way, just to have like 5 millimeters of space. Same with this. Okay, now we're going to put two M8 washers here and here, and then we'll drop cams, obviously one like that, oops, that fell out, and one like that, right? And then we take our spring, and we pull it over, there we go. Now you can see you have the spring, cam, motion, just like on the gimbal. So here's where we're going to use those lock washers from before. It goes there, whoops, there, and there. Those tighten down onto the lock washers. Now, because of the length of the bolt, I'm use this wrench and tighten it. There you go, nice and tight. Yep. Now, I can feel that this is rubbing a little bit here. Now, I think it's because the washers that I used in the kit are not thick enough to raise this up so it doesn't rub. So I'm going to use a second washer. You can feel it rubbing there, so I'm going to add a second washer there. I think what it is some of these are slightly different heights, and the one I was using before was taller. But that should keep, that goes there. Yeah, now it's not rubbing. There we go. There. Okay, that's much better. Mileage may vary. It might sit higher, might sit lower, so yeah, I just needed a second washer. So I'll have to go get another 2 washers because I'll need those later. There we go. Now that's nice and smooth. There's no friction. It's not rubbing there. Yep, you can see the cam. It's reacting with the pedal movement. You can see it's still, there's no center detent. So it's nice. You can move through center without any sort of clunk. Now, like the gimbals, you can also add a second spring. I don't think the second spring is typically necessary unless you're doing like an airliner where you want really heavy springs. But I'm just going to install the screws here and then grab this extra. They're all stuck together with magnets. Now, you can use all the same size spring because you're going to need another pair of these springs for the toe brakes. So if you buy a pack of springs, you can use all the same kind. This one is oh, this is actually, oops, a little bit long. Now the magnets, oh boy. Put that magnet there. I have a shorter magnet, or shorter spring that I use here. Drive those in. All right, so we have 2 magnets for extra force. But to be honest with you, I think just this magnet, or this spring, that feels pretty good. Like that's like a lighter sort of, like if I'm in a small private plane or a warbird or something, that's more what I would kind of expect. Maybe put that there. So it's just a little bit extra at the end. It's a little bit loose. Oh, it's because this spring is kinked, but we're gonna leave it off. I think we're just gonna go with the one light little spring there. That should be enough. Okay, so that's pretty good. Now I think the next thing we should do is the pedal needs to stand on something, especially since I'm scratching up this table. So the way that this mounts is with these pieces. Right, This is like the yoke that the pedal sits on. And then we have the extrusion, which are the feet. Now, there's a couple options, right? So for this front, so this is the back, this is the front. The front can have a bar going straight across. You can get, 4 of these bars. Or if you took this front bar and you chopped it in half, into 2 halves, you can actually do an angle at the front, like that. And these front pads that are for kind of your heel and also for balancing it, yeah, so it can either go in like that or at an angle. We're gonna do it at an angle. Yeah, so this front yoke, these are M5 by 20s, I think. Yes, 20. That takes a nut. That in there. By 20. Yeah, by 20. Looks a little bit long, but I think that's just the tolerance. Yeah, one there. One here. And then these ones here that you won't be able to get to once the pedals are mounted here. So that's why we're doing this step now. Yeah, put those there. Okay, so we're doing the angled. Just gonna rotate the damaged part there. Just kind of get that there. There we go. So those are our front feet. And then I believe these are 20s as well. Let me double check. No, this is 5 by 16. So there's one you gotta run all the way down there. Another one here. Okay, we got those there. So this angle is this way. Slide it up there. Put that one in. There we go. Now these are for putting little felt pad feet in there. You can also stick it on there. I don't have any felt pad feet with me right now, but that's just to protect the floor because this edge can be sharp. It's a little bit recessed, but still just to be safe. You can put something there. Same on the other side. This one's shorter, this one's longer. I'm actually going to slide that out a bit, just so that that's roughly the same. There you go. There's the front feet. And like I said, you can do it with a straight bar, you can do it with a curved bar, whatever preference. Now we've got the back yoke. It's the same thing, essentially, just putting those in there. That's the back. Now we need these pieces. Now these ones do have the felt put inside them from before, and I still had some. And then yeah, it's just a nut in there. Oh, wrong nuts. Drop that in there. M5 nut in there. And then we have this piece that you can set at different depths with these screws at the top to kind of place the space against the wall. So this part pushes against the wall. 5x16. By 16. Five by 16 with T-nut. Yeah, and then this goes backwards. And that's there we go. We have the front and back. Take this. Now we got to remove the bolts we added earlier. We take the front, slides right in there. Take M8 washers. So I will need another 2 for the back. Put that there. Some M5 washers for these guys at the top. Okay, same with the back. This has things that slides in over top like that. As this is now, it can still torque, right? It can still torque a little bit. So there are these pieces. Now these pieces have 2 configurations. I take them over. Now, if this was, you can see here, right, this has angle to it, and that wants to go like that, this way. If this was straight, it would still go here. If you're using the gimbal, where you have the rails coming this way, mounted here to here, this instead mounts to the side, and these holes go in to the side of that extrusion that comes through here for extra rigidity. But for now, we're just going to use it like that. See what I mean? Right? So this goes here because it has the cut. If it didn't have the cut and it was straight, it could go here. And like if it was mounted along that extrusion, it would go there. So this has 5x16. Just there. Okay. Oops. do the other one. 5x16. But because the main gimbal uses M6, we also use M6 here. So I have these M6 by 25. And these are going to come up. These guns go through here, and you can see it's actually labeled there, M6, right there. Those come down, okay? And this one, comes in through there. Same with the back here. Okay. And I have two kinds. I have these like locking nuts. Use that. Or you can use the standard nylon, standard nylon lock nut, whatever you have. Whatever you're going to use. I'm just going to finger tight these for now until I get the other side in so that everything's attached, and then we tighten. All right, I have my little thing there. I just kind of get that in the track. Now I'll try this on its side. Pick my bigger Allen wrench, Allen driver. Now these ones, because they have the teeth, I can just hand tighten them. Like just against the plastic. As they tighten, they grab. These ones at the top, I have to use pliers or a wrench or something just to hold them. Or tighten from the other side. Let me start with my finger. Now that that's all tight, we can tighten these ones. The other thing too is you want to make sure everything's flat, like on a flat surface, so that you tighten it, it doesn't have a bend to it, right? Because if I have a lip here, if I had it like half, then it could be off angle, and then I tighten it, it stays off angle. If you're doing straight pedals at this stage, it's just this piece. You loosen out this bolt that we put in the front of these. Take those off. Take these top ones off. Take these guys out, and then you just take the piece, stick it on, put the bolts in, right? Put the bolts on the side, and you're good to go. And then you have perfectly good helicopter pedals or Spitfire pedals or MiG pedals, anything that doesn't need toe brakes. This is really great, and you're basically done. If you want to add the damper system, that's an extra step, but besides that, you're basically ready to rock. So I would suggest, if this is kind of your first project, to kind of leave it here. Of course, you don't have to skip ahead to the setting up the electrical for the sensor, but besides that, mechanically, if this is your first rodeo, this is a good start point to stop, and then in the future, upgrade to the toe brakes. Of course, we're going to keep going. But speaking about dampers, let's actually install the damper system before we go much further, simply because it'll be more difficult to do it later. And in order to do that, I actually have to remove the back of this pedal. So I'm going to loosen that, same underneath. And then I can, actually I got to do it to both, I think. I have to take it off, but yeah, so loosen that. loosen this, take it off, because we need to put a piece back here, which is this piece. And yeah, it takes M5 by 8 bolts, I believe. I think it's 8. Yeah. And this is going to be another one of those very annoying to install because of all the T-nuts. Put those in, the 2 go up, and then you got to do battle with the extrusion, as always, to try and get it nicely lined up with the nuts. Okay, almost there, just this last one. There, okay. So that, we'll have to adjust the exact placement. I kind of put it flush against and then just pull it back by like a centimeter. We'll tighten that down. Okay, then I have my bolts for the damper kit. Now I believe the back one is a 40. What is it? It is a, yes, M5 or M8 by 40 with a nylon nut. That's going to go there. And at the front, it's a longer one. I think it's a 60. It's a 50. You could use an extra 60 if you had it. Which I do have it because I forgot earlier to put that in there. So I forgot about that one. We'll put that in later. But yeah, so that's the front. And that just takes a lock nut. Same with this one. But to mount this at the front, steering damper. So the extension goes this way, the ball head goes this way. Set it at the lowest setting, just so we're not fighting it as we're setting up. Okay. Or a longer bolt goes on the front here. And then that nylon nut goes up. There's a little recess for it so you can stick your finger in there. And then once it catches that nut, the recess will hold it tight so you can tighten against it. Just put that in there loose for now. Do the same in the back. Got the shorter bolt. Stick it in there. Same thing. Underneath there's a little spot. This one's not as deep, so you kind of have to hold with your finger. Oh, I actually have this backwards. The long bolt goes in the back. There's a little recess back there that that'll fit against. That goes here. Okay, that's good. Short bolt. Now you don't want these too tight because we want this to still be able to swing. Now this is loose because this one needs to be tightened. So you can see there's that little hexagonal slot that it's in there. So I just want to make sure that that's lined up into that slot. And then I tighten. So use a wrench to help me. Okay. This one's loose as well. Now, want it just at the edge of being tight. And it's got further to go. Okay, that's tight. Take it back just a little bit, just so it can still swing. And then you want to make sure to lift this up a bit so that it's not rubbing here. There we go. We can turn that up, add a ton of damping resistance to the pedals. Turn it down. Oh, I turned it up. Turn it all the way down. And then, so with this mounted, you can actually lose the rotary dampers in there. There's actually these holes at the top here, and there's on the bottom is actually for getting to the screws to take them out. If you upgrade to this, you can remove it without taking it all apart. Now this, when you gotta slide these back on, this will be a little bit of dancing around with these nuts again, but just straighten them out. Make it easier to slide in. Slide them up. Hope for the best. Yeah, first try. So, got our dampers. It feels really nice. It feels really nice. But we want to do toe brakes. So the toe brakes assembly, we're just going to do one because it's the same on either side. There's just one section that's mirrored, but besides that, it's the same. So let's start putting together the toe brakes. So we're going to set this aside. Now, toe brakes have a lot of pieces. This is the main base. This is what holds the magnets and the gear if we're using potentiometers. This is what holds the bearings. These are mirrored, so you need to get a mirrored pair. This is what holds the spring. This will be for the potentiometer if you use potentiometers for the toe brakes. And this is for the Hall effect sensor if you're using a Hall effect sensor instead of the potentiometer. This is an arm for holding the end of the spring. This is a optional TPU damper for the end of the brake pedal, just to add a little bit of progressive force. This is optional, but it's nice to have if you can print TPU. That goes with this. This is an optional insert because the pedals have two set positions. So if you're at the higher position, you'll need this spacer. This is for cable management. This is also for cable management. And this is the teeth for the potentiometer. Now, here's where we get into the part of the pedals that aren't entirely free. If you download the free plans, it comes with this Boeing style two-piece pedal. So you can have it like this if you want to have like a Boeing jet, and it has this little insert piece that you put in to add a tread that also makes it look like an Airbus pedal. So this is free with the plans. This comes with it. But if you're a Patreon subscriber or you buy the files directly on my Patreon, which is patreon.com/right-rudder-left-stick, you can get these, which are the combat pedals. So this is based on an FA18 pedal, and this will mount. Or we'll also have this Messerschmitt style pedal, which is a three-piece. Comes together like that. It has a heel mount. So these are what come for Patreon backers or for people who buy the files directly on my Patreon. And these were not the open source part this is what it comes with. So we'll install this. Now for this guy, this is what our pedals mount to. And it mounts to this. And it has these bearings. So let's insert our bearings into these pedal blocks, this friction fit. Okay, we got those. We can put these aside. Now for mounting our pedal, we'll actually do that later, but you can see these different mounting holes, different pedals use different holes. There's some holes at the face, which have recesses at the back for nuts. But this piece is what we have for our Hall effect sensor. So this takes 2 of our magnets, right? And try and keep the orientation the same so that, you know, north-south. It doesn't have to be north-south specifically, but it needs to be aligned with each other. And you can use a little dab of super glue to keep these in. I'm just going to friction fit them now. And yeah, just make sure that your next magnet is in the same orientation so that they're aligned with each other, right? They should be attracting each other. See that? And then there's a little recess here that just sockets in there. And then we're going to put an M3 by 12 bolt in through there. And we're just going to screw right into the plastic. There's printed threads. You could tap this, but it's only going to go in once and then you're just going to leave it. So let's just be legends. Yeah. You can see the smooth part of the gears, like of the wheel, is at the top. It only really goes in one way. Okay, that's in there. Make sure it's relatively straight. It's a little bit canted, but it should be okay. If it's a little bit twisted, it should be fine. Now, with these, we have to decide if we're doing left or right, because that'll affect how this part is going to go on. It can either go here, or it can go here. We're going to do this pedal, so it needs to go on the outside. Right, and that goes there. Now this also has threads, but we want these to be tight, so I don't think, if you can avoid it, you don't have to tap it. Like if you have, oh, that one's actually a nut, I think. But yeah, if you don't have to tap it, don't tap it. So yeah, so this goes here, like that, and then it's M4 by 16, I believe. Yes, M4 by 16, and that goes in here. Put that guy there. Oh, that's the wrong one. That's right. Okay, I'm just going to start that thread, and then there's one that goes here, and this one takes a nut. That one takes a M4 nut from behind here. The reason why this one takes a nut is because it's very load bearing, because it's, you know, the opposite of the spring, the arm that holds the spring. So putting a nut on it just helps make sure it really doesn't work itself out. Right. And you might need to clean up here. This is printed without supports, and you can see it's all mangled, but it's going to be covered, so don't worry about it. You just might need to clean up the hole a bit. Okay, that's in there. I'm going to tighten this side one down now. Oh yeah, that sound is good. That means it's really fucking up the plastic. It's really grinding up the plastic, so it'll be really bindy. You want to make sure this is flush, because this is, okay, that's there. Now, I need a M5. Okay, so this is supposed to take M5s that I don't have. I'm short by one M5 by 16. For some reason, I seem to have one missing. But these holes on the side dictate the angle in which the pedal moves, right? So there's two positions. The pedal can either be like that, or it can be like that, so it's more inclined. And these set the position for the stops on this. Now, these ones you should probably tap if it gives you any trouble, because you don't want this to crack. I've already tapped these, so I'm just gonna run it in. I'm just gonna use the lower position, I think. And this is either a 16 or a 20 mil, whatever fits in there, whatever floats your boat, so to speak. I seem to be short one of the 16s, which is a little bit unfortunate. I'm just gonna, for demonstration purposes, I'm actually gonna take this off. I would suggest doing this while it's attached, but it'll just be easier for me to film if I remove it. Yeah, just removing it makes it easier for me to film. So these, you see the little tongue here that sticks out, that fits in that slot. So we can take this off. Same with the bottom one. Okay, and that jumps in there. Now these look like they're countersunk holes, but it's just to make it print easier without support. It'll just get squished as you tighten them in. Okay, here a little bit of cracking, that's fine. That's just me crushing, I'm crushing the angle in the hole, so that's fine. Again, I want these to be flush, these are tight enough. Same on this side. So now we have this. These could be tapped if we want. These are M4s. You can tap them at this stage or later. Okay, now you can see these little recesses. You can kind of force that in there. Okay, good. Fine. Now through here, we take our M8 by 35 and our nylon lock nut, and we hold it. Oh, I already made a mistake. I made a mistake. This piece is actually a specific size. So this is mirrored, and this has this indent. It's actually supposed to be the other side. So these are actually directional. So this one is the wrong size. I need this size because this little thing slips into the detent here, and then there's a new detent here. It'll make sense in just a second. So now this has a little hole there. So when we do this part, this nut has somewhere to go. Okay. And then we run that nut bolt through, connect to our nylon nut in there. Same with the other side. Another nylon nut in there. Oops. I also say too, which you can see on this camera, if you install the combat pedals, these nuts are a little bit tricky to get into, so just be prepared that you're going to have to really fight to put a bolt through. These pedals don't use those holes, so don't worry about it if you're not using those. Yeah, now we can just tighten these on. Oh, just keep this nut in that groove. This one's giving me trouble. Because this one's giving me trouble, I'm just going to use the wrench in there just to keep it from spinning. You don't have to necessarily use nylon bolts here. On my main prototype, I just use regular or nylon nuts. I use regular nuts, but it's a peace of mind thing, right? Because this is a moving thing, so it might work itself out over time. Okay, see it's tight. This side, hopefully. Oh. Okay. Now we have our pedal. Okay, so this is at the low position, right? You can see it only moves there because this bolt restricts it. If we want to have it at the higher position, we loosen this out on both sides. Now we have the higher angle. Now you could have the full travel if you really wanted to, but it's a little bit too much for a toe brake. But yeah, so if we're at this position, we want to be at the higher angle, which makes more sense if you have the pedals further away from you. If the pedals are close to you, like at a desk, it's better to have it at the lower angle. But yeah, we'll put it there. Go. There's that. Now, remember this from before? That's where this goes. Now it has many positions it can be placed in. That sets the preload on the spring. I think for now we'll just use the middle two. And this is intended to be the same kind of spring you use here, so you can buy like a 4-pack of them, or if you're getting them in bulk. Sometimes they sell them in packs of 2, so then you get 2 packs of 2. And then you can put 2 on here, and then 1 on each toe brake. So here is going to be M4x12s. This one goes here. Yeah, this one goes here, and then this one will go down. Oops. This one might need to be tapped. Maybe not. I try and avoid tapping these ones because I don't want this to work itself out. Now there are nuts in the kit, or not in the kit, but in the bill of materials to put against the back here. If you want to use them as a lock nut, it's not a bad idea. Or not a lock nut, a jam nut. And there's that one there. Same here, just going in. Ooh. Trying to really fight having to tap these. I really want to avoid tapping this if I can, just for speed, but also I really want these screws not to move once they're in. And by making sure that they're not tapped, the plastic really grabs them, keeps them from moving. So now this is the spring, goes from here to here. That feels pretty nice. I mean, not really. You know why it doesn't feel real nice is because it doesn't feel like a brake, right? Now there's 2 things we have. We have this, and this inserts here, acts as a hard stop so that the pedal like when it gets to the end of travel, it actually stops, right? Because this will flex. Okay, so that'll be installed there. And that's just more of these M4x12s. Okay, so that's a hard stop at the end of the pedal travel. But the option with this TPU insert, that you just place it in there, it goes behind that little bolt there, right? And we lock it in with 2 more of those M12 or M4x12s. But that adds like a nice heavy progressive resistance. You know, it feels more like a brake. Okay. Now you can see in there, there's that circle that gets squished. Right, that provides much more progressive resistance instead of just this little spring. And I think it makes the pedal feel really great. Now, we have a choice to make here. We can either, in this design, we can either work with a Hall effect sensor, which is these 2 pieces, or these 3 pieces to work with a potentiometer. So let's just mock up the potentiometer version. So if I just grab this potentiometer I have kicking around, you just loosen that nut at the end there. Oops, lost the washer. And we can stick that in there, put the washer and the nut. Tighten that down. I'm just going to finger tight it because I'm not actually installing this fully. And then we've got this gear that has these 2 little teeth that line up with the gap here. You just slide that over. And we have this little plastic cover here. It just slides in there. You can glue this in to make it really firm if you want to, but it should, depending on your printer tolerances. This one's a little bit loose for some reason, but it should just snap in. And if not, you can glue it down. And then there's this hole here. Should we loosen this bolt? You can see how this hole is oblong, so we have a degree adjustment. So we'd run these wires, if we're actually using it, we'd run the wires up through there. But for now, I'm just going to have them hang out. And then you can see you then slide this until you get good engagement on the threads. Put that bolt back in. You can adjust the height of that until it's centered. And then you can see there, the gear is rotated. So then, yeah, you'd run these wires back, and then there's this piece that then goes here, and that's cable management, that cable will fit through. And that's where we use these extra 5mm bolts. And this also has side-to-side adjustment, so you can adjust for different thicknesses of wire. And then here, in order to make up the difference of the thickness, there's actual indents for the nuts. You can see there. Right, like it has a little recess, like elsewhere on different parts. So the nut can kind of sit in there. This is M5, as all these long bolts are all M5. Right. So if we're using that, that's where that would go. Now, technically, we can have both of these installed, but I'm just going to remove this other one because there's no reason you'd have both. So I can remove this guy completely. Okay, we're gonna just take this out. We're not using it. Put it there with the other one. So this is what we use with the potentiometer, with the Hall effect sensor. It's the same sort of idea. It has this up and down adjustment, but it has these two pieces. A little sensor there. And that, with the logo facing up, just fits in those tongs. Now you can put a little dab of super glue there, and then you would solder the wires as in the wiring diagram. In the expedience of time, we're not going to do soldering in this assembly. This is just going to be putting things together. So I'm just going to take this back out. Or actually, it's in there pretty good. It has a little detent that it clips into. Leave that in there now. So in the future, when we get to it, it'll already be in there. And then this is, again, M3 without tapping. You could tap it, maybe not, it depends. And yeah, depends on how it wants to go in, but that sits over top there, like that. Now, there is a space in there if you wanted to include a capacitor. Sometimes adding a decoupling capacitor, decoupling, is it decoupling? I don't know, I think it, whatever kind of capacitor. You place a capacitor there and it helps with noise. I find if you're using the Allegro sensor, not the SS49E sensor, you don't really need it. And if it's running at 5 volts especially, it doesn't seem to need it. But, you know, there's just a space, that little hole there for soldering a capacitor between, I think, the signal and the ground. Or signal and live. I don't know. When we get to electrical in a different video, we'll figure it out. So that just clamps here. I got these two bolts clamp these two parts together. Now the wire would be coming out this way. You loosen that out, this bolt down. Just like we did with the potentiometer. There's a little hole in there, right? And on the other side, we have our two magnets. Now, they're not glued in, so they keep falling out. They can't go very far, but we have those magnets that we inserted before. So that little hole that's in there, you can see that on this camera. That top piece goes into that hole, like with the sensor, right? So that just kind of falls in there, and then you just adjust it up and down on this mount here until it's in the center of that hole. You can kind of like half tighten it, and then just feel it around until it's in the center. Right, so I'm just like mostly tight, but I can still adjust, and then I can kind of look in there until it looks like it's not rubbing against any side of that hole, which means it's centered, and then we'll tighten that down. Now, of course, if we're using this side, then this should actually be on the other side, but I'm not going to bother flipping it now because there's no actual wire. And then that would then come back around and attach to that other end. Now, I can actually put this bolt back into my bolt circulation, which I guess explains why I was short these bolts, because it's only one or the other. Now, the last thing to do is to put our pedal on. Now, different pedals have different mounting. This one is simple, it's just these 3 screws, but they are the unfortunate part in that we do have a different kind of M5 by 20, because these ones are countersunk, right? So you can see how they have that little cone edge, so that's so that they sit countersunk, flush. So it's a little bit different, but this is fairly straightforward. We've got those places where those nuts insert, and we just drop the nut in. This one's a little bit tricky to do once this piece has been put on. So I kind of like set it there and just let it fall in. try not to scare the nut out. Just get it started with my fingers. Stick a finger in there, hold it. And then this one is Phillips for some reason. I guess I couldn't find the hex-headed version of these at the store. And yeah, and then we've got these two, which is these ones are easier to get to because you can get to the nut there. There's our toe brake. Yeah, that feels really nice. And it's got like a nice progressive force. Like you kind of have a little bit in it because of that TPU insert. Now you could use like a piece of cut foam if you got like packing foam, like that dense plasticky foam that they put like computer parts in. You cut a wedge to stick that in there too, but if you have TPU, you can print that part. And this is Boeing style, Boeing with this insert. It has little tabs here and here. Put that in. And now it's Airbus style. If you ever need to get it off, there's little spaces here for putting a screwdriver in, like a flathead screwdriver, and you can pop it back off. And there you go. There's that. And of course, if you're a Patreon backer, you could also have this style or this style to go on instead. But this is the one that comes for free, as well as this style with no toe brake at all. You can also use this. This also comes with the files. Now I have to fight to put this back on because I can't really get to this hole, this bolt anymore. So I'm gonna do that off camera, and I'm also gonna do the other pedal. Okay, great. So now we have the other side of our pedals done, just mirrored of the other side, with most of the parts being basically interchangeable, with the exception of the spring hook here. But yeah, we're ready to go. We can now proceed with some of the final touches on the mechanical. One thing I want to show, even though I'm not doing the soldering just yet, is how to run the wires. So the idea that I have for getting some cheap wire for doing this is to actually take old USB cables, USB 2 cables, oh not this one, but you know, the old style kind of crappy, you know, the mini ones that aren't really used anymore. I have a whole collection of those, and then chop them up. Right, so I can, you know, just take this guy, chop the end off of him, say he goes somewhere there, you know, just give it a little bit of a loop, and maybe, I don't know, it looks like 35, 40 centimeters to me. So say we'll do that, give it a little bit extra. Okay, take this. Give it another extension. Just so take two of them so they're the same length. I just want to show that this guy, it's got shielding around it, so you have to peel the shielding away. But then inside of the cable, actually, let me take more off. Yeah. Once you peel this shielding away, this has a bunch of protection for the signal, which is good for our sensor. You've got 4 conductors, which is, you know, we only need 3 of them, but what you can do is you have ground, power, and then you'll do left toe brake and right toe brake with the different colors. And then, yeah, so old USB cables, perfectly great way of doing it. And then, yeah, so that you can see this little cable management clip here. I can actually just pull it through. Since it's at the medium setting, you know, have that there. And then what I can use is these guys. That's an M8 with, or sorry, an M5 8mm with a T-nut. And I can run that onto extrusion there. So I can add a little loop here. And clamp that there. We can pretend like this wire is actually hooked up to something, right? And then that'll go into the back here. And we'll do the same with the other side. I'm not going to crimp it or strip it because I'm not actually doing the soldering in this video. This is just to show the assembly. we grab another one of our cable management pieces. Now this one, the reason why I wanted to show this should be on this side because we're using the Hall effect sensor. If we were using the potentiometer, we would go on this side, but we're using the Hall effect sensor. So we can just remove this, catch the nut at the bottom, and swing it around. Right. Take that up, out, swing it around. Because we don't want the wire to ever really get under here because it'll get smushed, right? So we want to make sure the wire is always coming out the side. Yeah, I can tuck that in there, pull that through, get myself a little bit of a service loop for later. Yep. Just gonna shove that in there. And then I'll just push against my thumb while I tighten that down, just so that this cable is being nicely grabbed. And if this isn't grabbing the cable enough, you can put a little bit of tape around it. You just don't want this to be, you know, rubbing and wearing itself out. Okay. Do the same thing here. Clip that around. Tuck that in there. And that'll go into the back here where we're going to mount our electronics. So we have some choices to make here. You know, here's a completed board from the gimbal with the USB port that's added, the blue pill. It's got all the headers on it. It's got the extra stuff for extra sticks. You know, you can also have the raw board and, you know, solder it directly. Or what you can do, and this is only, you know, a really good idea if you already have one that you bought for the gimbal because they have a minimum order, I think, of 5. So if you have an extra one, you can use it here. And then the way that would mount is that we have this piece here that then lines up with the holes. And then that goes here. But with this, we also have pieces that can just take a blue pill directly, right? So I can take my little blue pill in here. It's got a little clip there, and then we can wire into that. Do the same thing with an Arduino Micro, Pro Micro. Right, I can just tuck that in there, lock that in, USB port. Now, what that means is you'll need to have like a right angle connector, you know? So we take this guy here, and then you'll have to have the wire come out, right? Or this guy, have the wire come out. But basically, this is the adapter plate. So let's pretend like we're gonna mount a completed board, but the procedure for the other ones would be basically the same, right? We take our completed board, we take our M3x6s, should have a couple left. We just have these holes in the PCB here. And I can just mount directly there, right? Okay, now we have it all 4 mounted. Now this thing is supposed to be adaptable for, you know, different things, you know, different adapter plates. I know that there are some pre-made solutions that you can just wire these directly into and it handles all of it. So, you know, this area back here will be adaptable for whatever electronics that you want to hook up. I'm just using this one because I have it all set up. These holes could also be tapped, but I think I can just tap them with the bolts as they go in. Just saves me having to bring the tap out again. To make sure they go in straight. Right. I should have one for each corner. actually, one thing I forgot to say before we mount this. Before we mount this, let's wait on mounting that, is the cable that we just cut up. This is what goes down to the sensor. Now, in this version of the file that I've printed, I don't have enough space that I can feed the wire down in there because it's too narrow of a channel. I've since widened this channel in the part that you'll be able to print, but for now it's much too thin of a thing. Like I could, if I disassembled it, I could shove the wire in there. If I use like smaller, you know, these wires, I can get it in there no problem, right? Like there's enough space for that, but if it's like a big USB cable, it's too much. So this will be enlarged before you guys get to it. But let's just, for, you know, sake of argument, say we've attached that wire and it's come out of here, right? So that wire that's threaded through that channel, I shove it in there. You know, if I've shoved that wire through there, for sake of argument, say that I have the wires going through there. This is what we have to close in on the bottom. There's another M5 bolt here. I don't remember what this was added for. I don't think you need it, but it's still in the plans. And anything you can do to make the gimbal base more rigid is for the best. Yes, I'll just run that into the plastic there. It's just threaded right in. There's no nut or anything. There you go. Okay, that's mounted there. Now, we have a choice to make here. How do we want to run this sensor? We can, with a magnet, if I can find where the magnet went. Here it is. We can have the same magnets we're using in the toe brakes. We can just drop that right in there. Or if we're using the magno-resistive kit that we got from AliExpress that's also used with the gimbal, what we would do is we would use that little magnet, this little round magnet, and you would place that into that slot like you do. At some point, I want to modify the main gimbal to also be able to support the larger magnets because I've got, and this is the same mounting hole spacing for that. Because the reason why I say that is because I've also got this piece, right? And the Allegro sensor goes in there. So the same sensor we're using in the toe brakes. It goes in there like that. I believe it's the flat side up here. And then you would just then bend these three legs down. And then of course solder to them, right? And then this piece here goes over top just to kind of sandwich it in there, right? And now the reason why we tapped these holes in the beginning is so that this is easier to do. And this is going to be M3 by 12. It's longer ones. And those go through here like that. All right. And then we can bolt that sensor down. Yep, there you go. That's bolted in. There's the magnet behind there. You could glue that magnet in to keep it from falling out, or you can friction fit, depends on your tolerances. And now these first bolts that we put in, you can and of course, pretend like this wire actually fits in that slot and it goes down there. With those bolts removed, we now have this dust cover. Just keeps the wires from getting tangled. And that just clips in there. And then you reinsert these bolts on either side. There we go. And now if you're using this potentiometer in there to do the potentiometer gimbal in there, like for the yaw, the wires would come out here instead of coming through this hole, obviously. But we will imagine that the wires are coming up and then out and through. We're not actually going to attach the wires today. That'll be for a separate video. Okay, that's pretty good. Got that on there. Now we have this piece. Now this has some options to it. It has the ability for the wire to come out the bottom or through the side. It has this piece that's supposed to line up with this USB port, or a piece with a hole so that there's just a cable coming out, you know, if you just have the wire. There's also a variation that's the other way, right? It's a different print. And there's also a solid one. Because we have this USB port, we can use this piece that lines up with the USB port. Just insert them in there. We have to take these bolts out of the side. Hopefully the nuts don't fall on us. And this should take a washer as well. We didn't put washers on it before, but we'll use washers now. Right? Now there's these little grooves here. That's where these wires are going to go. Right, so we would wire these up. I believe I have to make the pin out guide. That's why I'm not filming the soldering yet of which pins here, but those will go to there, those will go to there. This one goes to here. Or, you know, you would solder directly to the board. But for now, we're just going to tuck them in there. Deal with them in the future. It's a future problem. Right. Tuck those there, in there. Okay, we take our bolts, with the washers, stick them in there. Oops. There we go. Get that side started. You have to fight against the wire a bit because it wants to push it away. There you go. And just get the bolts most of the way started and then. Okay, and now because we have that insert there, we can use our USB A-type cable and it'll fits in there like that. And then with that, this guy is now complete. So we've got all the moving parts, very nice rudder action with adjustable damping. These cams can be easily swapped out. Just loosen these bolts, lift it off, put different cams in. Toe brakes. Alternate pedal types, so we can mount that. Or we can mount that on either side. We've got Hall effect sensors. We have the option for using potentiometers if you're a little bit less advanced or you don't have, access or experience. Or you can use Hall effect, or you can use magno-resistive. This can mount directly to the base of the gimbal, or this can mount to whatever your sim rig. Or with these things, it can push against the wall, so you can really push that against with a little bit of adjustment. And yeah, so that's the build guide on how to build the pedals. So now let's get into doing the electrical. It's much simpler than the gimbal, and there's a new sensor option that I'm going to focus on, and I'm also going to focus on doing this with Freejoy. The breakout board is a leftover from the gimbal, so it's optional. You can just wire directly to the blue pill itself, but that's how the guide's going to go. And this new sensor is going to be backported to the main gimbal as well, so you can also build the stick gimbal using it. So you can decide if you're going to use the breakout board that was from the stick, or you can use the blue pill mounted directly, or in the same sort of mount, use a Pro Micro board as the microcontroller. I think what we're going to use is the breakout board that we currently have installed with the blue pill. Now we have the existing wires that we installed when we were putting the stick together that are cut USB, and then we also have a wire that we need to run down to this position. So this is the primary axis which we detect the pedals on, and now we can use the same kind of sensors we're going to use in the toe brakes, which is the little Allegro Hall effect sensors, which we can mount there just directly over the magnet and run the wire down. Or we can use the same kind of sensors that were originally recommended for the main gimbal, which is the TLE5010. But what we actually want to use is this AS5600 sensor, which are commonly used as encoders for motors. They're very easy to come by, but there's one limitation that they have. They have a 360-degree sensitivity, which means we have very bad resolution for the limited range that we're going to be using. So we have this technique that we're going to reduce the range of the sensor by using the blue pill and connecting it over the I2C bus so that we can program the chip directly and restrict its range to about 50 degrees instead of the full 360. So let's set that up. In order to program the chip, we have to connect to it over I2C using the blue pill. So we're going to have to solder in the headers on the board so that we can communicate it with it in order to write the commands that set the range. So let's solder on the headers now. So now that we have those headers soldered on, we can now connect to our blue pill here. We're going to need to connect the power to the VCC and the ground, and then we'll need to connect to something called the SDA and then the SCL, which are the data lines for I2C. I'm just going to put on a graphic up on the screen now just to show you what you're supposed to plug into. But once you have those plugged in, we'll be ready to program. So just like how you would flash Freejoy onto the blue pill with the ST-Link dongle, we're going to flash this custom binary that I've made onto the chip before we do the blue pill firmware. So we're just going to burn this onto the device using ST-Link. It takes a while sometimes for it to upload. And then we're going to use this for programming our chip. Now, if it's programmed correctly, we should see this flashing light. That means the script is running and we're good to go. We want to double check that everything's connected there, and then we want to short the pin, which is A1, to the ground pin. We just want to just touch it once, and once it goes into ground, we should then see 3 quick flashes, and that means it's done. It's burnt. We can disconnect everything, and our chip should be ready to go. Now we're going to want to hook up the analog out, which is these 3 pins here. And this is where the range has now been selected. So we have 25 degrees either side of that wipe. So we're going to make sure whenever we mount this sensor, it's mounted correctly using these 3 headers as reference. Now you can only burn these chips once, so you want to label it so you don't accidentally ruin it by trying to burn it again. And speaking about burning, you're going to have to reflash the Freejoy firmware back onto the blue pill after you've done this process. So now we can grab the mount that will hold the breakout board. Has the same spacing as the original Hall effect board that we can also use, but that just goes in here. We want to make sure that the north pole of the magnet is aligned with the sensor because we have a very specific range. So you can see here on the original pedals, we're going to pop this magnet out, the larger one that we were using for the old Hall effect sensor, and we're going to put the little one in, and we want to use like a little compass or something, or some labeled magnet that we can detect. So here the north pole is pointing to the south end, so we want to make the north pole on the compass, or sorry, the south pole on the compass to point in the right direction, and that'll tell us. So yeah, north there is pointing to the south end of the magnet, which means we have the right orientation. And we have to be fairly precise because we only have maybe 10 degrees of margin. And we use the tip of a very fine screwdriver to hold it, and that'll balance the magnetic pole. Currently we're touching the south pole, and we'll verify with the magnet. Yeah, that's the right way. And while it's delicately balanced on, whoop, I messed it up. Delicately balanced on the top of that screwdriver, we then push it into the mount. We might take a couple of tries to do this. It's a little bit tricky, but we just line it up and then push it into the hole, and we stick a little bit, or first we'll verify that the magnet orientation is right. It looks good. Some electrical tape or Kapton tape or something, just to keep the magnet from falling out when it's in use. And now we can take the sensor. Remember, we want the analog pins facing north, and I'm also just labeling the back with voltage and ground just so I can not get confused when I'm doing it later. And yeah, we just want to align it there, and we can use our little bracket that just goes into the 4 holes on the breakout board, and we align it there, and then we just screw it into the base of the pedals. Now here's an alternate consideration. Earlier on when you're building the pedals, there was an option to use a potentiometer for this axis. So if we just take the gear off of this potentiometer here and mount it, we can use it on all the axes of the pedals if you don't want to deal with a Hall effect sensor. And I think this is a 15 millimeter long stem from the base of the threads, and then the actual part of the top, the twisting part, is about 7 millimeters. So that's the size of potentiometer that fits in this pocket here, because there's a maximum height in which can fit in this space. But there's this little bracket piece here. It has a little ridge or like ledge that goes towards the gear, so you just want to line that up. You can see it here, that faces towards the gear, so the pins need to be going the other way to be heading back to the microcontroller. So we just attach it there, put the washer and the nut in just to tighten it down. And then on the top of the potentiometer where there's the split, there's the arrow on the gear itself that lines up with that split, and if you put it on there, it should go right on. You can just pressure fit it in. Then there's 2 little M3 bolts that go in there. And you want to make sure that the potentiometer is wound in such a way that it does move against the gear, that it's not jammed up against one of the stops. And you also want to adjust a couple of teeth off of the end stop because there are dead zones at either end of the potentiometer. So you don't want to be using that part of the range. But once you have it nicely lined up, it should mesh with the gears. You want to tighten those M3 bolts in nicely so that it's nicely firm against the gears, and you can use this as an alternative way of controlling the input of the rudder axis. Yeah, and now what we're going to have to do is run the wire, which, because of a version of this file, there isn't a thick enough track for the wire to fit down, so I have to kind of disassemble it, basically take the entire back yoke off of the pedals so I can run the wire. The version that you guys should be printing should have enough space that you should be able to just push the wire through to get it to the back. But here I had to kind of do some open heart surgery. And here I'm actually using a fan header extension, but you could solder directly to these pins. I just need 3 wires to go down, and then I'm feeding it through and reattaching everything. You just need a VCC, ground, and a signal wire. So I'm running it through to the back here, and then I need to trim the wire, and I'm putting a set of Dupont connectors onto the end of it because this is a prototype and I have headers on the breakout board, so it allows me to swap the microcontroller out and other things like that, you can solder just straight to the breakout board, or you can solder directly to the blue pill or whatever microcontroller you're going to use for running the pedals themselves. But for me, it's just very convenient just to add these Dupont connectors onto the wires. It's not really necessary. And I'm going to do that to the USB cables that we cut up to use for the pedal sensors as well. I'm going a little bit more detail here in that I'm color coding. One is going to be green, the other one is going to be red. And in the USB, there's a white and a green data cable. I'm using white for one of them, and I'm using the green color for the other, just so I can identify them. But I have to make sure that's consistent as I go to the sensors on the toes themselves. I have to also make sure I'm matching the same colors. So whatever wire you end up using, just make sure it's organized. Again, you just need a ground, a power, and a signal line. So 3 wires. USB with these nice flexible USB cable I cut up has 4. So yeah, it's perfectly fine. And I'm also putting the Dupont connectors on there just because it's a lot easier. And now we can stick the final wires in and put the blue pill microcontroller onto the breakout board. So it just sockets in there with the USB wires down. It's very tricky still to get blue pills that aren't counterfeit, but the AliExpress store called We Act Studio, that seems to be selling legitimate blue pills. So it should work with Freejoy, but I mean, mileage may vary, so buy ones that are, from a real company. And then with the blue pill, of course, you can use the big USB, or you can have a USB cable coming directly out of the board, and then it comes out of the housing. It has these little pockets that you can swap out different modules for whether or not you're going to have a cable coming out of towards the chassis or away from the chassis, just by selecting which insert goes in there so the cable is coming down. You can also use a 90-degree USB-C cable to make it come out the side. And then you can have the cable strain relieved in that little pocket there. Yeah, either going against the chassis, or there's a different variation of this piece that goes around the other way that actually goes in all the way. Now, using a Pro Micro, you can't use the USB on the breakout board because it doesn't have USB headers on the pins themselves. So that one you'll definitely need to use some sort of USB cable, either a right angle or coming straight out of the bottom. And the other thing too is that these wires, you'll have to merge them if you're connecting without the breakout board, because there's shared ground and there's shared power pins. It's not that complicated just to splice some cables together. So yeah, now that we've got all our wires hooked up at the back here, we can close it all up. Screw it all back together, make sure that the USB, however it's going into the board, is all hooked up. Now we need to move on to the other end of the cables for the toe brakes and actually wire them up to the Hall effect sensors. So we're going to have to get in there, but one step that we should do before we get started is to actually remove the springs from all the axes, just so they'll be easier to work with. Then we're going to want to remove the Hall effect sensors mounts that are in the toe brakes. So we just got to unscrew this. You might need to loosen some stuff to get clearance, but yeah, then we need to get this piece out. And then we have the Hall effect sensor that we mounted in from before. It's in there, so we're going to have to disassemble it to get the sensor out. So if you're doing this for the first time, it might make sense to do all the wiring while you're assembling it, but here we kind of have to work backwards. You can use a flathead screwdriver to just poke in the edge here just to force this sensor out of the little clip that it's mounted in. In this case, I think there's a little bit of glue, but it just pops right out. And yep, now we got to strip the other end of the cable that we connected to the control board there, remembering the colored wires that we ended up selecting. And then if we wanted to connect the potentiometer, we would connect it also at this end, and then it interfaces with those gear teeth at the bottom there. You just have to keep in mind with the pinout of a potentiometer is going to be different than the pinout on the Hall effect sensor. The other important thing to remember is the orientation of the Hall effect sensor is the beveled part is up. So when you see the label, that's the up face of it. So then we just want to go in and tin all the edges of the wires here and of the Hall effect sensor, just so they have solder on both sides. That'll get it ready for us to connect them. So we just tin each of the wires, we line up the power, then the ground, and then the last one will be the signal wire. And once they're all nicely connected, I'm just going to take a piece of electrical tape and wrap it around the middle wire. That way the wires on the edge can't short against the middle wire and against each other. That just nicely protects it. And then once we're ready to go with that, we can clip it back into, with the face up, into the little holder there. And that just fits right in that slot. Now on the mounting bracket, there's this little opening here, and that is for installing an optional decoupling capacitor that goes between the ground and the power, and it just fits in that little hole. It's optional, but we're going to use the software denoising in Freejoy. So we can put it all back together, reattaching the M3 screws here that kind of clamp it into this module, and then we're going to reinsert it into the pedals. A little extra step I'm going to do is I'm just going to put a little bit of electrical tape wrapped around here just to keep this Hall effect sensor from falling out. Just something that's a peace of mind. And on this side I ended up having a big trouble getting this back in, and I had to pull the bolt out to get the nut out of the way so I could insert this module back into the little pocket in the gear with the magnets. But once I was able to get that nut out, I was able to put it in and just adjust it so it's centered with the axis, and you just repeat the same process on the other side with the other pedal. I just have to remember to make sure that I use the same color that I used on the other end that goes to the microcontroller, and this side went in a lot easier because it didn't have that nut in the way. And now we have both the cables. I spent some time just adjusting the clamps that are holding the wires in the back and wrapping electrical tape in there just to keep them from sliding around because we don't want any rubbing. But there was a lot of finicking and adjusting. You want to make sure that there's no pinch points. There's no chance that the wire can wrap itself around a nut and then pull itself. So just spend a little bit of time just to adjust all the fitment of these cables along the back of the pedals, just so that when you're using it and it's tucked away, you don't suddenly snap a wire. So now you can hook up the USB cable and launch the Freejoy configurator. Now you're going to want to go to the GitHub and go to the electrical section, and then the Freejoy section, and then the configuration, and then you'll find the configuration file that you can load onto your blue pill once it's flashed with Freejoy, which is a good basis because all the pins are already assigned, but you'll have to do the calibration stage, which we'll get to now. We've got the springs taken off, which will make everything easier to set up. And we've got the range here. So you can see the bottom line is the raw value. Top line is the outputted value. And we can see because we burned earlier, before we put Freejoy on here, we have a much wider sweep of the raw value than we otherwise would have had. And then of course we have the toe brake. Now the toe brake, you know, you can see over the full range, we're getting very little travel on it. So that's why we do the burn effect. For the brakes, it's not super important. This one's disconnected for something. Don't worry about it for now. It's the same procedure for both. So what we'll do is I'll just run calibrate. So we hit the calibrate button, which is currently on that axis. And we just have the start position and then just step on it and let go. And then that'll save the start and stop positions. For the rudder axis, just kind of put it to the full ranges. Okay, stop and save. And then if this was connected, I would also do the calibration for the right pedal, but it's currently disconnected. So then I go right configurations to device, then it'll refresh, and then you can see the red line is what Windows sees. So the red line contains the actual input. And you can see here, as I press down on the toe brake, you can see that line here go up. And that's it. And you obviously do the same thing when that's connected. But there's one last procedure of calibration that we'll want to do, is we'll want to reattach the mainspring on our rudder axis. That's because I want to kind of wiggle it a little bit just so it finds its center. Then once we have it, we say on the rudder axis, set center, right configurations to device. And then that'll save on this axis that is the center position. Now there'll be a little bit of sloppiness to that center. It won't always go perfectly to center. So you can, if you want, if you hit the show extended settings on that axis, you can then add a dead band, which makes a dead zone in the middle of the position, but it's fine. Unless you're flying like something like a space sim or something, you don't really need to have a dead zone. It's not critical, like, you know, for warbirds or something. It's such a small amount that it's probably not worth bothering with it. And then of course, if you really want to eliminate that sloppiness, is that you take this bolt that's here and you drill down into the aluminum extrusion and you tighten this bolt into the aluminum directly, and that'll get rid of any of the twists. Because what's happening is this plastic here that has the roller on it is just deforming ever so slightly, which makes it so that it doesn't always land exactly the same spot. So you would just blow through that aluminum and then run the longer bolt through, and then that'll get rid of that. But yeah, so there we go. We've got our rudder axis, we got our toe brake axis, and we're ready to go. So yeah. I really want to thank my Patreons. Without you guys, none of this would have been possible. All the filament and all the hardware has been supported, and this printer right here has been supported by contributions from my Patreons. At the Patreon, they have access to early versions of the files, as well as the Fusion working files, and any sort of side projects that I put together. So if you'd like to join the Patreon, you can go to patreon.com/rightrudderleftstick. But there's also other places that we can interact in the community. There's a really great HOTAS Discord channel. If you go to the HOTAS subreddit, there'll be an invitation in the column there, but I can also pin a comment in this video. On the Discord, there's a sub channel called Very Big Stick, and there's the community exchanging ideas and feedback and all the different work in progress projects that people are doing, so definitely check that out. I really want to thank my Patreons. It's an incredible community that have really come together and supported open hardware and open design. It really is an incredible group, and I am so appreciative and so thankful for all that you've done to help us get to this point. And I really want to also thank the Spiral Dive and, of course, Catastrophic Loss of Speed tiers. You guys are the real MVPs of this project. Without you guys, it would not have been possible for me to replace my printer and continue on. So yeah, if anybody wants to join the Patreon community, that's really fantastic. But of course, this is a free and open design released under Creative Commons, so there's no obligation to join or to support the project financially directly. I really want this project to be accessible to as many people as possible. So please, if you're interested in making one of these or designing something of your own, absolutely join our community, join our Discord, reach out. Thanks.